Hey guys, hope all of us are doing fine. My name is Ernest, and this is Ernest Sciences and Mathematics TV channel. In this specific discussion, I'm going to look at the derivatives of the inverse trigonometric functions. And basically, we are going to look at this with the main objective of trying to monitor the relationship between this specific aspect of derivatives and, of course, the concept of integrals. Now, in our previous discussions, I've basically said that we're going to have a close relationship between integrals and derivatives. And this is going to be one of the strategies that we're going to use in trying to find one from another. So in this case, we're going to see that for us to find the inverse trigonometric functions, there are some specific results which we are going to come up with, which are going to assist us in trying to particularly try to evaluate the concept of integrals. Now we shall look at the, of course, differentiation of inverse trigonometric functions for the three basic, of course, trigonometric ratios. And that is going to be for the sine, the cosine, and of course the tan given in that specific order. So therefore, we are going to evaluate various, of course, a range of functions. So we shall start with this specific function of the derivative of the sine inverse given as such of x. So we shall as well look at the concept of this derivative of the sine or the cosine inverse of x given as such. And then lastly, we're going to look at the evaluation of particularly the cosine or the tan inverse of this specific function of x given as such. So these are going to be assisting us find various terms or results which I've said, which are going to assist us in trying to make it easier for us to evaluate the concept of antiderivatives, which basically are going to be our integrals. And in this case, we're going to consider the first case and have it that if we are going to have y represent this specific, of course, inverse function of the sine, then this implies that basically x can be represented in terms of this sine of y given as such. So from this specific representation, we can define the concept of the derivative with respect to x given as such, whereby we're going to borrow from the concept of identity. So in our previous discussion, we have said that we can have the relationship between cosine and sine given using this specific representation, whereby the square of the two are going to be forming a unit. So therefore, we can represent the various aspects of the sine of y using this specific derivation, whereby we are going to have the sine of y represented as the positive or negative value of the difference between 1 and, of course, this specific aspect of the cosine square of y given as such. So we shall have this one given as such. So we're going to see that we can derive this specific aspect of the sine of y using that specific representation. And as well, we can find the cosine of y given using this particular representation of the square of 1 minus the sine of y, the square of the sine of y given as such. So in this case, in case we use these two particular representations for this specific derivation of the sine of y, then therefore it's going to be more understood for us. So in case we have this specific ratio for the d over dx over this specific function, this is going to be the derivative of this particular function which we have given in terms of x. So therefore, we are going to find the derivative of this specific sine of y given as x, which is going to be giving us what we give as the cosine of y. But in this case, I've said that we can represent the cosine of y using this specific, of course, representation. So that implies that we can represent this specific value for the dx over dy given as a positive or minus the root of 1 minus the sine of y. But I've said that we can represent the sine of y using this specific function over x. So basically, that implies that 1 minus the square of the sine of y, which is equivalent to the square of x given as such. So basically, we're going to see that in these two specific ratios for the sine and the cosine of y, we're going to have this particular function for the sine inverse of x representing what we refer to as an increasing So we have talked about the concept of increasing and decreasing functions. So this is going to form an increasing function whose specific derivative for this one is going to be giving us a positive value. So we're going to consider this one given in terms of a dx all over dy, which is equivalent to the positive value of 1 minus the square of x given as such. So therefore this implies that if we have this specific function for the dy over dx, which has been of course interchanged, we can have this one represented as dy over dx, which basically implies the derivative of y with respect to x. So this is going to be the derivative of y, which implies that basically we're going to have this specific derivative, which is going to be the sine inverse of x given as such. And this is going to be giving us the value of 1 all over the root of 1 minus x squared given as such. So this is going to be representing the derivative of the sine inverse of x given as such, and this is going to be forming one of the aspects which we are going to come across. So using the same analogy, we can derive the function of the cosine of this, and of course the cos inverse of this specific function. And from of course evaluations, then therefore we are going to consider having this specific function of the cosine inverse, whereby we're going to see that if we had this specific function, so we can just have it such. So let's have this particular function. So I'm going to reserve that result so that in case we are going to make a reference with it, and therefore it will be easier for us. So we are going to have the finding the cos inverse over x, which was going to be our second option in this particular case. So we're going to use the same relationship whereby we're going to have x representing the cos inverse of x given as such. So this implies that x is a value which we are going to find as the cosine of y. So in this particular case, we are going to find the dx all over dy of this specific function, which is basically going to be given in terms of a negative the sine of y. So in this case, if we are trying to represent it from this specific, of course, function, then therefore we can have it given as a dy all over dx of this particular function, and that is going to be giving us the value of course, so we shall have positive or negative the root of this specific function, which is going to be given in terms of 1 minus, so we have decided that we can give the sine of y using this, or the cosine of y using this specific. So there's a confirmation I wanted us. So perhaps it will be important for us to try and represent this specific value for the sine. So which is going to be given in terms of a positive or minus the root of 1 minus. So the value of x squared is going to be representing, of course, the square of the sine of y is going to be representing a value for x. So this is going to be the value of the square of x given as such. So we have said that we are going to have this one represented as a dx over dy. So that one implies that we're going to have a dy over dx as a function which is going to be given in terms of a 1 all over the root of 1 minus x squared given as such. But for the sine function, we're going to see that this basically is going to be a negative value. So we shall have this one given in terms of a negative 1 all over the root of x minus x squared given as such. So this is going to be giving us the value for this specific function, which is going to be the cosine inverse over x. And if we try to look at this one, this is going to be implying the d over dx over the cosine inverse over x. So from our previous discussion, we said that dy all over dx is equivalent to 1 all over increasing function for the sine inverse is going to be given for 1 minus x squared. So in this case, I had mentioned that this is going to be representing d over dx over the sine inverse over x given as such. So the relationship between the two, as we can see, so basically the similar representation, only with a difference for the a specific representation for the cos inverse, which is going to be a negative value, and for the sine we are implied that basically it's going to be forming what we refer to as an increasing function, and therefore these are going to be defining the two sets of values for the first two options we had for the sine and the cosine inverse of those two particular functions. So let's look at the last case whereby we are going to be required to evaluate the tan inverse, or the derivative of the tan inverse of that particular function. and try to see how we can basically represent it. Now for the tan inverse, we're going to have this one, so I can simply change the first one for us to do an evaluation with this one. So we're going to have the tan inverse of a function x given as such. So we say let y represent the tan inverse of x. So this implies that x is equivalent to the tan of y. So from our previous discussion, we had said that we're going to have the derivative of this specific function of a tan given in terms of the square of a sec. So we're going to have a dx all over dy representing the square of a sec over x given as such. And that is going to be forming what we refer to as our basically a derivative for that. So this is equivalent to, from identities, we're going to see that this is going to be given as a, so perhaps I can give this one given as such, but sec squared x is equivalent to 1 plus the square over the tan. So we're going to have this one represented as, so we shall have this function over, so let's have this one given as such, the square of that one. So we are going to have this one given as the sec over y, since we're going to use y as our function. So in this particular case, the derivative of our x, which represents the tan of y with respect to y, is going to be giving us a sec y. So in this a general case which we are going to borrow from, whereby the sec squared over x is equivalent to this one. So this implies that if we are going to have basically y, then therefore we can just adjust this specific equation to represent our scenario for the sec over y. And we have said that basically the second set is going to be forming our value for x. So this implies that we are going to have 1 plus the value of x squared given as such. And this is going to be representing the sec squared of y given as such, which is a derivative of this specific, of course, the tan of y. So we are going to have a dx all over a dy, which is going to be our derivative in this case for the tan inverse. And this is going to be representing our value for the function, which is going to be 1 plus x squared given as such. So this basically is going to be forming our derivative for the tan inverse over x. And I'm going to have this specific representation for this particular value which I've given for the tan inverse over x given as such. So perhaps we can have it as such, and try to look at it with the other representations which we have had for the cosine, sine, and the tan, and try to see what are some of the relationships which we are going to see from this. So suppose we have this one, which was our first representation, which we said was a d over dx of the sine inverse over x given as such. So this is equivalent to 1 all over the root of 1 minus x squared given as such. And we said that for the option 2, we had d all over dx, the cosine inverse over x, and this was negative value of 1 all over the root of 1 minus x squared given as such. And lastly, we said that we are going to have this specific representation for d over dx of the tan inverse over x given in terms of the value of this particular function of 1 all over 1 plus x squared. So if we try to look at these three specific representations, as I said, we're going to have a relationship between the concept of inverse, which, or rather integrals, which is going to be for a form of antiderivatives, and therefore we can use this specific representation for us to find various integral functions of forms which are going to be similar to this one. For instance, if we consider the case for the first, of course, case which we are going to have for the derivative of the sine inverse of this specific function. So this implies that for the first two cases, this implies that we're going to have the integral of 1 all over, or the integral of dx all over this specific function of 1 minus x. So this is going to be the square of x, 1 minus the square of x given as such. So this can be evaluated, and of course we're going to see that this is going to be giving us the sine inverse over x plus c. And if you look at the second case for the integral of the cos inverse of this function, which is going to be dx all over the root of 1 minus x squared of this particular function. And this is going to be giving us the respective values which we are going to obtain for the, of course, a negative value. So in this case, we are going to consider the cos of this specific function, which we said is going to be forming a negative value. So this is going to be giving us the cosine inverse over x plus c. And let's look at the term which is going to be giving us, so kindly confirm for this second case. So let's look for the term which is going to be giving us the integral over dx all over 1 plus x squared. So this is going to be giving us the value of the tan inverse over x plus c given as such. So in our way, these particular functions are going to be assisting us try to evaluate the antiderivatives of their respective functions. And this is going to be one of the easier ways or an application of these particular derivatives of inverse trigonometric function. Now, in a sense, I've said that they are going to form an easier route for us to find or evaluate of other various forms of integrals which are going to be having such a kind of a formation which are going to be similar to the results of this, of course, inverse of these three basic trigonometric functions. So kindly check our description boxes for various links of other videos. Engage us in the comment section and also ring that notification bell for other updates on our different discussion in math and sciences. So that is it for now, guys. Bye. God bless you. Catch us in our next video.